Welcome to this next talk titled Arcane and Internal RAG System to Pinpoint Investment Policies by Dr. Ehsan Amjadian. Prior to introducing our esteemed speaker, let me just go over some house rules. Immediately after the talk, if you have any questions, please just raise your hands and my coordinator will come to you. Without any further ado, let me introduce our speaker. Dr. Ehsan Amjadian is the head of AI Solution Acceleration and Innovation at RBC. He earned his PhD in Deep Learning, Natural Language Processing from Carleton University. He's currently the head of AI and data at RBC, where he's leading the development of privacy-respecting AI products for our customers' digital journeys with an emphasis on digital payment. He has over 15 years of experience in the field of AI. At RBC, he has led numerous advanced AI products from ideation to production and has filed for multiple patents in various areas. He is an adjunct professor of computer science at University of Waterloo and has published in a variety of additional artificial intelligence and computer science fields, including but not limited to cybersecurity, recommendation engines, information extraction, and computer vision. Please welcome Dr. Amjadian.
Right. Thank you, kindly, for the intro. I'm really glad to be here. And there are parts of this talk I'm going to reference some previous presentations. If you're a TMLS recurrent attendee, you're going to get those references. But how many of you have been, for how many of you this is the first time you've been TMLS? First time. Okay, so a lot of first timers. All right, sounds good. All right, let's get started. I'm going to move a bit faster and then leave some time for questions. We can come always back to the points that you're interested in. All right, so let's talk about Arcane. It's an internal RAG system to pinpoint investment policies. We worked on the pilot side of it. So we tested everything in production. However, taking it and scaling it up and use it, to millions and millions of users. That's something that our partner Borealis AI, you may have heard of them. They're the AI kind of branch of the enterprise RBCR. And I had AI and data within the payments function. That's where your cards are, your digital payments, physical payments, POS devices. So a lot of fun stuff to happen there. We develop our technology there, and sometimes in collaboration with other enterprise, teams, and sometimes on our own. Okay, so this specifically was developed by us. So we're solution acceleration and innovation. And we very quickly innovate and create things and test them in our setup. And then when they're ready, they can move up to a permanent home. So that's about our organization. Our organization, as mentioned earlier, is very well versed in payments and payment technology. We go all the way back to creating the online payments or the online system, let alone mobile, and nowadays, almost everywhere in your digital world. So let's move to RAG. So how many of you already know RAG? Okay, I guess so, right? So I'm not going to tell you what RAG is. Maybe a very brief intro. But so what we hope to do here is talk about a little bit of the methods, how things are built. I'm not going to go too deep. You all know. Some top challenges you're going to learn. Some of the lessons learned from doing this in a very specific domain, as you will see, inside very large organizations such as ours in the financial domain, and some do's and don'ts, and some privacy security and privacy and security and safety considerations. I'm not going to focus too much. I have an hour-long talk. Probably, I believe I already recorded in TMLS on that topic, right? So. And you had a keynote today talking about some of the issues with ML inference in general. Okay, so let's move. So what's the problem? So financial operations are complex. How many of you are from fintech or the financial domain? Okay, so some of you, good to see some of you. How many of you are from RBC? Just checking the competitor space here. All right, good. So the left side are the outsiders, guys. Just be careful. Good, very good. So the financial domain is very complex and very large, right? So these are just a few of the very complex domains. Obviously, everywhere you can apply automation and intelligence. You can apply RAG. We get to the house a little bit later. So core banking systems and the convoluted, layers and layers of wrappers. Like that's already super complex. The ATMs, online banking on its own, treasury management, mobile obviously getting bigger and bigger, more important. The biggest point of entry, asset liability, foreign exchange, and a vertical horizontal conglomerate investment. So types of investments. So the second, so let's look at the problem that I have at hand for this RAG system. So this RAG system is used for direct investment, as you will see in some of them later on. And it takes years, and not just in direct investment space, but in all these financial domains. Well, some of them way more complex than others. And do we have any quants in the room? Okay, no. So if you ask a quant, it's very complex and very kind of accountable line of work. So things are can be super complex. Anyhow, it takes years to train these people in whatever expertise they come from, and these people are already highly trained. So usually come with 5 to 10 years of post-secondary studies in STEM a lot of times, and sometimes even in more having done a graduate study. So highly trained individuals. And there's a backlog of the most specialized set of people that need to be reached at a certain point in time. That creates a bottleneck for that service, now be it investment, be it wealth management, be it PNCP or any of the other pillars, right? So that's a bottleneck and that's a problem. And every second can be, can have really multiplicative productivity impacts, usually resulting in millions of dollars in bottom lines, right? Let that sink a little bit, and making our services most competitive and time efficient. So let's take a look at a solution. So there's nothing proprietary for this one. Everyone has seen, knows what a RAG system is. So I'm not gonna jump into too much detail. Any specific questions, ask, and if it's not proprietary, I'll talk about it. So this is what it looks like. I kindly ask you not to take a picture of the slides that I'm actually showing the RAG system. So this is what the kind of experience looks like, really. We've put in kind of a few really most frequent questions that get asked by the advisors for this specific use case. And there is a question you can ask, obviously. So there is that kind of the chat interface. Really nothing revolutionary, but specific for this kind of this function. And what you notice to the left is that chat memory or chat management, right? And that's really, really helpful, especially if you're an agent that specializes in a subdomain. That gets tricky, so we'll talk about it a bit later. So here are some of the questions you can ask in the domain. You can ask about the HBP program, the home buyer's plan, if I remember correctly. And I'll let you read it a little bit. I'm just going to pause for 10 seconds. Right, and this is not the most kind of complex question, and obviously so, because the most complex ones is our kind of secret sauce, so we're not going to talk about them here. Or some other knowledge question: are there any fees to withdraw money from HBP? I think all of you know the value of RAG, as opposed to really part of the problem, and we get to it a little bit later, is that all this information is not created in a structured manner. right? It's not like a database you can ask an exact query and get the exact response, right? So, and that's a big hassle for a newer agent, right? Or even not years and years of seasoning get to the information that really answers the client's question, right? So anyhow, there is more. If there is interest, we'll come back to it, right? So in conditions of identifying a home buyer, the first-time home buyer, who is it not? What amount of limit to withdraw, and questions regarding spouse or more, how family comes to play. Let's move on quickly to the top challenges. So I mentioned the issue is, really one of the biggest issues, and I would say actually the biggest issue that we faced was the fact that we're dealing with semi-structured data, right? Let me see. Do I have a question for you? No, I don't have a question. So semi-structured data, a prototypical semi-structured data is anything that XML-like format. So that's HTML. So that's your PDF files. That's your websites, right? Internal, external, what have you. And they're the hardest really to utilize. Maybe if it's entirely unstructured, maybe a little bit easier than that. But really finding the pieces of information to index them is not easy, and that's why search is so time-consuming, right? You're bringing a few results back, and then it just takes so long for the advisor to get to the right piece of information, right? And also there are irregularities. It looks like it's structured, right? It looks like you have your headers, but and web development has been there for a while, but it's still not consistent, right? So you can easily get a developer, tagging or structuring their HTML file way differently than the other, and all it takes is to use a different set of tags to make it impossible to find a piece of information, right? Okay, so that was a big old bottleneck. And what's the solution to that? So the solution to that is to have a really good parser and make sure all your sources of data are properly and can be properly parsed. Some of them cannot. So if your PDF files, I don't know how old your files are, but if they're images, obviously the parsing would be way different than some newer PDF format. So all right, so parsing is the biggest part. Now the other part is evaluation, right? So I have a couple of questions for us to just get us started, and then we'll jump a little bit more into the details. So why is RAG evaluation important? I take a volunteer. Go for it. And I'll repeat it. So.
So from my day-to-day experience, we have some non-deterministic aspects in the RAG system. For example, like retrieval of, let's say, chunks from vector databases, the indexing and the parameters you use with it is impacting the recall, let's say, as well as, you're relying on LLMs that are not always, most of the time, like non-deterministic as well.
Yeah, sounds good. So what's just maybe a couple of words. What's the biggest risk? What can go wrong for a RAG system?
So you might not have the most relevant or sometimes wrong answers,
exactly.
Right?
Yeah, exactly. So lack of proper response, so just tells you something that's really not useful, irrelevant. Or worse, false, right? That's called the hallucination. All that you've probably heard about it quite enough, but I'm going to delve a little bit deeper. And we need to stop that. And hallucination is a little bit harder to deal with because if it's not relevant, you just say it's not relevant. If it looks relevant, you may be misadvised, right? And just go ahead and follow that advice, or worse. letting our client know, misinforming the client, right? So it's very important. Then it is how to evaluate RAG systems. So there is no perfect solution, but a combination of methods will get you to a very safe space, right? So I'm going to talk about 2 RAG methods, so 2 RAG evaluation methods. How many of you are already familiar with RAGs? Just checking. Oh, wow, that's awesome. Okay, so everybody's using it. So it's open source, as you know. So that's why we went with it. And it's a very good complement to what we already use in information retrieval. Your precision and recall, your hit and misses, right? And all it adds to the left is your faithfulness and answer relevancy. I'm going to spend a bit of time just to cover my bases. We go to the next ones because it's an important part of the talk. So your precision and recall, you got them context because your context is really referring to your chunks, right? The parsed documents, right? So again, that's why really parsing is so important. And the generation bit was what gave a lot of people problem at first. Like, okay, the chunk looks good, but there are so many reasons generation can go wrong. How can I measure that, right? So we got together and reused some of the metrics that we already knew how to use. So we get to it in a second, but conceptually, your faithfulness. So precision and recall, I suspect most of you are familiar with. Very briefly, precision is from the ones that from the claims that you're making about the data, how many of them are correct, right? And recall is from the correct answers out there in the world, how many of them you're retrieving, right? So that's really good for information retrieval. That's how we did search. And with faithfulness, we get how factually accurate is the generated answer. So you can see the 2 players now. It's answer versus the context that gives the information, and how relevant is the generated answer to the question, right? So you can be very accurate. You give the right answer regarding a context, but not at all relevant to the query, right? So and vice versa. Right. So RAG is the one that we use actually. Obviously it's pipeline index. You can pip install it. So that's handy. And here are some of the metrics we can use. Some of them, right? So I'm going to go through them very quickly. If need be, we can come back to it. I think precision recall we kind of covered. So it's very easy. And F-score is the harmonic mean of them. So and to the right is the retrieval metrics, and you got the mean reciprocal rank, especially if you want only the top document. In this case, and for RAG in general, especially internally, I do not recommend MRR because you usually have source of information. It's semi-structured, so you may have your information scattered between chunks. So that's one of the biggest learnings we'll talk about maybe at the end as well. MAP is good though, mean average precision. All right, so let's move to the relevance and faithfulness. Well, obviously you can use human eval, no-brainer. You can use auto fact-checking tools. You can use consistency checks. How many times? I think that the first 2 are rather self-explanatory, so I'm just going to focus a little bit on the consistency checks. Top left. So, the idea is if you're giving it the same query or different versions of the same query and you get a response, it is more likely than not that the answer is correct. So the model knows actually. If you can convince the model otherwise, it's usually the answer is incorrect. I get that type of response when I ask about consciousness or things that are controversial. It's very, if you have access to an unfiltered model, it's easy to make it flip between what it actually believes. All right, so, and for the relevance, you can use the traditional machine translation metrics, blue summarization metrics, rouge, meteor, and machine translation. Or what I really like to use, because it's very, it's more semantic, is the embedding-based approaches, right? Your sentence birds and a simple cosine similarity, if you're using a large enough model, is very reliable. smaller models can have can be very volatile, right? So those are, I think, the main points I wanted to make. Let's move on quickly. So, and this kind of triad, you see a lot of similarities between this and RAGAS, as you saw earlier. This is done by True Era, but I really like their visualization. So there are a lot of similarities. I really like the visualization because you get the context relevance defining a query and the relationship between the query and the context. You got your response and the answer relevance, the relationship between your response and query, and you get your groundness score, which is the relationship between your context and response. And all of this is text, right? So, so very, you can use the exact same metrics that we talk about. This conceptually, maybe slightly different than RAGAS. So let's move to lessons learned. Okay, so as with any other software solution, you got to profile your solution, and I just don't mean by that I don't just mean the compute bottleneck, right? The bottleneck in general, where things gonna go wrong, and what would need most of the effort. For us, it was the parsing. Without proper parsing and chunking of the data, it's very hard, even with the best LLMs out there, to get to the right piece of information. Especially because these are highly, highly specialized materials. A lot of them are internal, so these models would have never had a chance to have seen them, even if they're trained on all Bloomberg data and all financial data. So these are proprietary pieces of information. And the knowledge may not exist. It could be just organizational knowledge, right? So it's very important to detect those bottlenecks, right? And vector databases were not the bottleneck. However, how to use them was important. If I'm not jumping too much ahead, I'm going to wait on that point. We'll get to it in a second. All right, so first things first, just common sense. Don't throw RAG at things. You get it for technologically biased individuals like myself, who will have to contain myself, not to use the latest for everything, and also not technologically very well informed individuals, like people with purely business background, right? Want to throw the biggest tool and see how it works. If you're a technical person, you can tell, is it going to be useful or not? So, don't shy away from telling your partner that. And the cursor joint probabilities. So, as you noticed, we want to have memory. We want to have an ongoing conversation. So the model can rely. You don't have to re-explain things. That is not easy, especially on something that the model has not learned and is just using RAG to augment that knowledge, right? So that's a big risk. So if you ask 5 questions back to back, chances that the 5th question is absolutely false is very high. Is very, very high, although you have the answer there. So how to help that? Very careful COT or prompt engineering. Will it be absolutely successful? No, because you talked about quite a few points, and the model can get confused as to what really the good answer is, right? Unless you do it for do as much training or fine tuning. But usually that takes a lot of data, and is a bit of cost consideration, right? The other risk is that you go that 5th question down the row, the answer will look very convincing, right? So just knowing that and kind of which brings me to one of the next points, educating the user is very important. There is no way you can take on all that risk systematically and systemically. So you will have to have some sort of guardrail in place for your humans and how they use the device, and that education you cannot replace it any other way, right? And I'll get to some of the examples in a second. All right, they need to know what's real and what's not real. I think I talked about it a little bit regarding the tech and biz conflict earlier, but they also need to know what risks are relevant and what aren't. So let's talk about the risks a little bit. Give me 1 second. Yeah, I have it down there. So we'll get to it in a second. Let me stay at the technical side. So. And in general, for generation, use your best model. For embeddings, you can use smaller models. Yes, it does matter to use better models for embedding as well. You all know where the difference between the embedding model and the generation, right? Get enough nods, okay? All right, so maybe very high level, your embeddings you use for your indexing and retrieval, and your generation to interpret the message back to the client, right? So, and what we noticed for 3.5, absolutely, like obviously it's very, very fast, no issue, and your GPT-4 was slow, right? So the pilot we ended it a few months ago, so I'm not sure if you've seen considerable improvement as to what it was, but GPT-4 was very slow. GPT-4 Turbo was a bit better, but still slow, right? Now, is it a showstopper? No, it's not. The clients can still use them. Yeah, that's fine. It's better than waiting minutes on a call. All right, so some security and privacy considerations. I know, I did mention that there is an hour-long talk on this, in a previous TMLS. So if you have access to the digital content, take a look. I'm going to mention a few ones very high level here. There I go into detail on some of the methods and how to mitigate them. But model inversion. How many of you are familiar with model inversion? Okay, some of you. So it's a privacy attack. You can steal a model that you have programmatically access to, right? If you have access to an API, you can attack it consistently. After a certain number of attacks, you pretty much can reconstruct the training data set and reconstruct the model. So you can just retrain the model on the data that you get. And that's one way of doing this. Multiple other ways to do that. What I want to say is that don't take model security for granted. A lot of times in traditional encryption, compute is not secured, right? And models do run on, in runtime, right? So that's you get exposure, and that's you can have a lot of these attacks even without direct access to the model. So there is prompt injection that you can have the model spit out information that it's seen. So that's especially important for these use cases where you have proprietary information, access to proprietary information, and the model has seen them. So be careful if you fine-tune it. So let me talk about external and internal endpoints. I teased it a little bit before. It really matters where you're running the model. Some of them are on the cloud. Some of them are on some sort of a VPC, virtual private network. If you can run it internally, please do so. RAG is not really the most expensive use case depending on how big the user base is, right? So it's not that expensive to achieve RAG internally. And you have a lot of choices when it comes to models, right? If you can use it internal. For external, there are a lot of considerations that come in, especially if you're in a heavily regulated space such as ours. Yes, so let me stop there. So DLP, very important. A lot of things can go wrong. Much time to get into the detail, but we can talk about it. And we talked about hallucination, right? And one way to ensure it is the trifactor that I kind of indicated throughout the talk. I repeat it once more. Make sure you evaluate properly. Make sure you educate, and make sure you have systemic security, right? That we indicated. So that's a talk. I'm glad to take any questions. Do we have time for that? Or?
3 minutes.
You have 3 minutes for questions. Yes.
Yeah, so you mentioned about one of the biggest pain points was around chunking. So I know that's a big topic, right? Like chunking strategies and all that. But anything you can share there, because even on my own, like that, dealing with
Yeah.
as much context as I can, but sometimes
Yeah.
it can backfire.
Right.
So anything you
Right.
can share there?
Yeah, I share some of the generic ones, and for detailed ones, it may differ on the really what type of text you're using and what the context is. But in general, the chunks have to really be meaningful, pieces of information. Something that you look at is like, oh, if I want to find this specific piece of information, I can find it. A lot of times, if you cut them in the wrong place, they're not going to be helpful. Like, just imagine part of the if you have an important part of the message in a different paragraph and you chunk in between, it's very hard to retrieve it back, even if you have a really good RAG system in place. It's very hard to put it back and give it to the clients, especially if it's very scattered. But that's a high level. We're done? Okay. Yes, I'll be available to talk outside for sure. Thank you.